All right. So hopefully you've all had the chance to watch the video. And let's go ahead and open up Canvas. If you haven't, just try to do your best to watch those because it'll be very useful for you. Well, it's kind of necessary to understand how generics work. I believe that your professors for 1068, which would have been either Hani or Sarolis, would have gone over array lists a bit. They're not too bad. As we've learned, as I went over in the videos, they're kind of like lists are essentially what we want arrays to be, which is that they automatically expand for us if we remove something, it automatically shifts things over, so we can actually modify them in a way that makes sense to us. And it's worth noting that if you worked in Python, that those lists were never arrays; they were always lists. They were always array lists. It just did everything for you under the hood and treated them like arrays because that made everything quicker. Now, with regards to So let's go ahead and pull up the assignment that we're going over right now. So again, these are quizzes to see if you want that will help you check your understanding. I updated the syllabus to reflect that those quizzes should only be worth 5% of the grade rather than 10%. So I believe the current update, so the syllabus should be updated. You can go to the assignments. 5% for the quizzes, 30% for the assignments, and then 20, 20, and 25 for the exams, respectively. Okay, so list functions. So I would suggest doing these all in one class because they're all static methods, meaning they're not associated with anything. You do not have to make your own array list or use the myArrayList that I built in the files. This one I'm expecting you to use the built-in ArrayList method, the built-in ArrayList library here. So we're given 5 problems, and I'll start you off by making some of the method headers so you can see how that works. So we've got 6, 5 of which you'll have to do all by yourself, and one of which I'll go over, at 10 o'clock. So the first is uniqueness, which given so we're going to have a method called unique. It's going to take in a list and returns true if all the items in the list are unique. And I'll use list and array list often interchangeably here. Remember, list is the interface, and array list is the implementation of the interface. An array list is a list. Let's go ahead and start that off by new project. We're going to call it array list exercises 2023. Or I'll call it TUJ, actually. Here we go. And this window. And let's go ahead and I will make my source file for that. New source file. Call it exercises. Okay. So now we've got ourselves public, static. And the first thing we want to do is that this is a Boolean. So we're going to write this unique method. Unique. And then I'll add in the rest of the modifiers. Okay. It's going to return a Boolean statement. Okay. Public stack Boolean unique. It takes in a list, and I'll quantify that later. I let the IDE do all the imports for me. So list, and I'll call it underscore list because, hey, why not? Remember that class names in Java are always capitalized. If you find that confusing, then don't use the same word. Use what works for you. I just try to always use a name rather than a letter, a single letter. So, and for this one, for a lot of these Boolean things, saying if this is one thing, return true. If it's not, return false, I always find it best to like try to prove that by contradiction. In other words, assume something and assume assume that it's true. Like for this one, it's easy to assume that they're all unique items, and then it's easier to disprove it. So in other words, I'll assume return true, and then I'm going to try to disprove it. And you'll see me make this mistake quite a bit, where I capitalize true because in Python it's capitalized, and in Java it's lowercase. Again, that kind of thing as you learn multiple programming languages, it's going to happen. Don't worry about it when you do it as well. Okay. Now, as you see here, so again, what this method is going to do is that's going to check are all the items in this different? Are they not equal to each other? As you see here, this is highlighted yellow, which means there's a warning here, and it gives me something saying that it is a raw use of the parameterized class list. This is kind of because generics weren't initially built into Java. They were added, I think, in Java 1.5 or Java version 5 for comparison. They switched from going by 1 point something to calling it like Java 7 or Java 8 around Java 7. So it wasn't added in, so you could use things without generics. But now if you use something without a generic, it gives you a warning saying, hey, you really should use a generic. This shouldn't just be because if you don't use a generic, this is what it assumes. It assumes it's a list of objects, which could be anything. It's got to assume that because you didn't specify, so it could be anything. So if you don't specify, it's going to tell you it's a list of objects. What we want to do, though, is that we will use this marker over here. So over here, I did public static, and then I said this is a generic type marker. This tells Java, hold up, there's a generic type here. It's E. E is essentially going to be a variable for a type. We don't know what it is yet. When will we know what it is? When we call this method. If I pass in a list of integers, all those E's will suddenly be integers. If I pass in a list of strings, all those E's will be strings. So that's how the header for this works. Public static E, Boolean unique, a list of E's. So this takes in a list of E's where E is some type. So that is the first problem. And again, this simply checks, and here you'll want to use the dot equals operator to check if two things are equal. There's a second question is, questions 2 and question 3 are very similar, which ask you to create a new list based off of certain conditions. So all multiples says, hey, give me a list of integers and a integer and tell me or not whether or not they are, give me a list that has all the things that are divisible by that number, all the things that are multiples of the number. That comes out to being the same thing. So public static, let's see, it's going to be returning a list, and I'll add the generics in a minute, even though I'm like saying, you got to add them right now. But I got to tell you what it is for pedagogical purposes. Int num. Okay, so, and return, I'm going to return, I don't like it if I never write code that ever has, I don't like to ever leave my code having errors, even if I'm going to have to go back and change that null, which I am. So over here, one of the common mistakes we see when you're starting generics is that you put in okay, it's a list of integers, so I'm going to put in integer over here. And this is going to cause some very interesting issues later on, because what you do when you know what the type is, you don't need this parameter over here. What this is saying is that public static, hold up Java, in here, there's a generic type, and I'm going to call that generic type integer. So whenever you see integer, replace it with whatever you got passed in. And as a result, I'll show you over here, integer x is equal to 5, and I get an error, right? Normally, if I don't do this, that's fine. But if I suddenly have this over here, what it's saying is that it's integer is just like an object. We don't know what kind of thing it is yet because it's in generic type. He never told me. It's basically what happened is that like I renamed. I overshadowed something. I essentially renamed integer rather than being a type. It's now basically a variable name. That's what happened there. So when you know what the type is, basically only like use capital letters in here is what I'm saying. Only if you know what something is, then just say so. I want to return a list of integers. And I'm going to take in a list of integer. I don't have to figure out what it is later. Make sense? That's probably the biggest hurdle to get around. And then what we'll do over here is that we will, to return that, I will just simply create a new list over here. Let's see, new list, and I'll call it output. New array list, and then I'll return the output over there. So everything else will happen in between that, right? It's generally good practice just to make sure that you're using that you kind of name your variables in advance. So list of integer, output. Now, because I called this a list, this takes in any list. It could be a linked list or an array list. We'll learn about linked lists later. But here we're explicitly saying that our output is going to be, we're creating our output to be an array list. And that's fine. Okay. Problem 3 is very similar. You're just doing it for strings. Problem 4 is permutation. That takes in 2 list objects that contain the same type. So in other words, a list of e's again. And now you're going to return true if they're permutations of each other, or false if they're not. Permutations basically means that if you're unfamiliar with that term from statistics, or if you just need a refresher, that means that they need to have they're the same items just in different order. So for instance, if we're talking words, the English words wolf and flow are permutations of each other. They both have the same letters, they're just in different orders. One way to figure out if 2 things are permutations is by sorting them, right? For instance, over here, if I've got 5, 3, 1, 2, 5, 3, 1, 2, 4, 3, 1, 2, 5, and I've got 5, 2, 1, 3, 4, both of those are permutations of each other, and we can tell because if you sorted them, they'd be exactly the same. That's one way to tell if they're permutations. That only, however, I caution you that only works for things that you can actually sort, which is not everything. Not all types can be sorted. In order to be sorted, they have to be well ordered, or there has to be total ordering, a partial ordering actually. You have to have a way to order things. I forget the exact term from modern algebra. And so just be aware of that. The other way to solve this is and the way we're going to go over in class, actually we're going to go over a few ways, is that you count all the items, is that you look at each item and count how many times it occurs in the one list and how many times it occurs in the other list. The first move you want to do, regardless though, is make sure your 2 lists are of the same length, because if they're of different lengths, there's no way they can be permutations of each other, right? Because you're just going to have too many items of one thing. It's essentially the pigeonhole principle, if you're familiar with that for statistics. In other words, if you're matching too many things up, you're going to have one too many match or one match left out in the cold. All right. String to list of words is interesting. We're taking a string and we are converting it into a list of words. The split method, as I mentioned in the footnotes, the split method does a whole lot of things. And this is kind of our first example of where you can see regular expressions in real life. and I give you a regular expression that helps you match things. Now, there's extra credit here that's available, where if you take in hello world and you do it without extra credit, it should just be hello, comma, world exclamation point. So you don't worry about the punctuation unless you want the extra credit, in which case remove the punctuation for extra credit. Okay, make sense? 2.6 is my tricky one, because for you to understand what's going to go on there and to code this one correctly, you got to understand how the array list works internally. So this one's called remove all instances. Takes in a list and an item. So we then remove every item in the list that matches the item. So here, let's say our input is 1456552, and the integer 5, we remove all the 5s from the list. Make sense? So so the list changes to become 1462. All the 5s are gone. It is very important that you test this on this case where we use where on this input and see if you get this output. Because a lot of times, if you think about it and just code it up directly, you should get an extra 5 left over. One of the 5s will be left over. And if that happens, don't worry. It's just you've never had to think about how these things work internally. And so that's kind of why, so you'll definitely want to look at that and see how to get that. There's about like 4 different ways to fix it. Once you hit that, there's about 4 different workarounds. They're all right. All of them are okay. So after that, once you're done, just call me over and I can check them over to make sure that they work. Because that's part of the reason I do the demos rather than just having you submit. Because like with 2.6, you could think it's right, and then I'll give you a test case and kind of show you that, oh, it's maybe not working. And I don't want you to get into that dead end and just miss out on the learning opportunity. What's worth noting is that all these functions will be used in the next assignment. They'll be used in assignment 3, the big O assignment, where you'll do a big O analysis a runtime analysis of these programs and figure out, okay, what's the big O of this? And it's probably linear or quadratic depending on the function. No, definitely not consonant. Oh. All right. Any questions on any of these? Again, I go over 2.4 in class because that's definitely a trickier one, but I do want you to try that yourself. Although it's not so much tricky as that it's ugly to write. It's the way you have to write it feels wrong because of the way you have to loop over the same thing a few times. All right. So what I'll do now is I'm going to go around and I can either answer your questions on this and or check you get your demo for and run the grader for assignment 1.